Welcome to Math 1B Unit 7 Basic Geometric Concepts. This is the second lesson in Unit 7. In this lesson, we will learn to identify and name all of these. Let's read them. Points, lines, segments, rays, angles, parallel lines, perpendicular lines, radius, and I'm going to add this in, diameter of a circle. Just a reminder, you need to take notes on this. You must have notes of this and submit them to me either through Google Classroom or an email. I want to see your notes just to make sure that you have these references ready to go. I want you to use these definitions and examples and references in your mastery tests to come. Okay, so what we're building today is an important set of tools that you're going to use for the rest of the unit and beyond. So take notes. It will prepare you for the mastery test afterwards. Here we go. Now, we've already spoken yesterday about points, lines, and planes. Let's look at them again. A point is a single spot or location. We name them generally through a capital letter, like point A or point B or point Y, for example. A line, hopefully you remember from yesterday, is the space between and extending through 2 points. So all the points that extend endlessly in both directions through a set of 2 points. So we have to have at least 2, like point A and point B here, to create a line. But it's not just the points in between A and B, is it? It's extending endlessly in both directions. And that's signified by the arrows, the way I drew this. So when you are doing geometry, using the symbols is important. So the arrows at the end is signifying that it's going on forever, leftwards and rightwards. Okay, now for a segment. A segment is all the points in between 2 points. So this is more limited than a line. So I've got 2 points, and we're including all the points of A and B, and then those in between. A segment is cut off at A and B, or at the 2 endpoints. It doesn't extend endlessly like a line does. Now for ray, a ray has 1 endpoint, and then points going endlessly in the other direction. I'm going to rephrase what I have on my lesson here. Points going endlessly in the other direction. So you have to have 1 endpoint, like point A, and then it goes forever the other way. So this is a mix between a segment and a line. Next up, angles. Angles you can think of as the amount of turn or the amount of space between 2 lines, segments, or rays. So here's some examples. Let's say we have 2 rays coming off of point A. So I have ray AB right here. And let's say we have another point C, and we connect A to C and make a ray out of it. So we have ray AB and ray AC. In between this space here, this amount of turn is the angle, okay? So when we talk about angles, we're talking about how wide this space is or how narrow the space is. Every angle has a certain measure. Oops. These are measured in degrees. Measured in degrees. So for example, they can be anywhere from 0 degrees all the way through 360 degrees. And we're going to look at some more concrete examples of this in a second. So here's some common angle measures. The full circle, it's like starting at really any point, but starting here and going all the way around until you end up back where it started. This is 360 degrees. A straight line or half circle, again, we start just like the last one. So starting here, but we only go in a half circle. So it goes up, keeps turning, and then stops right here, making a straight line. This is 180 degrees, half of 360. Try it on your own. Take 360, divide that in half, you get 180. A right angle, I know you've seen these and heard this before, used them before. A right angle is the same as a quarter circle. So if we start from the same position, and then we go up half of a half of the straight line, and we stop right here, this creates a right angle. We usually signify right angles with that little box, so you're going to use that too. This means right angle. And these are 90 degrees, which is half of 180. And that makes sense because this shape that we're looking at is half the shape of the half circle above. There's even more angle measures that you will come across. Before we do these, I want to look at some more angle measures with you. So if you have a really narrow one, there's ways to actually measure the proper amount. But I would just want you to see some more examples before we move on. Um, you could have a very thin angle of 20 degrees. Maybe if you if this went up one little degree higher, then it would become a 21. 21 degrees. Or if you took the 20 degree one click lower, like going down a little bit, then that could become a 19. So basically all the different angles in between 0 and 360 exist. We will be looking at a lot of those ones we just covered here. So be prepared to use these often. 90 degrees for a right angle, 180 degrees for a straight line or a half circle, and then a full rotation all the way around and back where you started is 360. Okay, now let's have a word on parallel lines. Now remember, parallel lines are two lines that never cross. Two lines that never cross. From an algebra point of view, parallel lines have equal slopes. So that will come into play again in our lives. Just remember, parallel lines have equal slopes. They go in the same direction. I'm going to add on have equal slopes. The same amount of up and over, up and over. That's why they never cross. That's why they go in the same direction. Perpendicular lines. These are two lines that cross at a very specific angle. They cross at a 90-degree angle. So a common example of perpendicular lines are we've been graphing a lot in the yx coordinate plane. Well, you know instinctively that y goes straight up and down and x goes straight left and right. These two lines that we're used to graphing in are a right angle. So that means these two lines, the axes, are perpendicular. Now, this is not the only example of perpendicular lines. What if I just made up a new one here? We have line AB, and then we have line CD intersecting somewhere at a perfect right angle. Well, that means these two lines are perpendicular. Okay, not the axis, but these are both examples of perpendicular lines. Now, a word on circles. The technical definition for a circle is all the points that are the same distance from a common center. Think about that for a second. We have a center right here. So let's say we pick a distance. Let's say we pick 5 feet, right? And here's 5 feet away from C. So here's the point that's 5 feet away from C. But what about 5 feet in the other direction? So here's another point that's 5 feet away. What about 5 feet in this direction? If you were to kind of collect all those points that are 5 feet away from your common center, it creates, and look at my picture's not perfect, it creates a circle. I'm going to create a new circle on the right here. Okay. Let me try that again. It is hard to draw a perfect circle, isn't it? Freehand. Let me try it again. Okay, that'll have to do. So here's a new circle. I want to say a word on the radius and the diameter. The radius is the distance from the center out to the edge of the circle. It's important to understand that all radii are equal to each other. So let's say we had this labeled and our center is point C, and let's say the first radius I drew is out to point A. What if we had point B as another point on our circle's edge? Well, if you draw segment CB, that is the same length as segment CA. All radii are equal. Let me add that on for your notes. Make sure this gets in your notes. All radii for the same circle, for a given circle, are equal. Now, there's another term that's important for us in a circle, and that's the diameter. The diameter is the distance through the center that goes from one edge to the other. So let's look at our circle on the right. We have segment CA made already. What if segment CA extended below till it hit the other side? Like this. We'll go ahead and call that point D. So now we have segment AD or DA. Those are, you can read it either way. And if I were to go ahead and extend CB on the top part right here to a new spot at E, point E, these are both diameters. EB is a diameter and DA is a diameter. Therefore, for this circle we've made, segment DA is equal in length to segment EB. Add this onto your notes. All diameters for a given circle are equal. So if we know the length of one diameter, that can help us find the length of another diameter if they ask for it. All right, now a few examples to put all these terms and ideas to use. Example 1. It's a bit blurry, but I hope you can see this image I have here. We've got some crossing lines, some intersecting lines at different, and they're all labeled actually by a full letter, it looks like. So I think I would have made this a little differently, and maybe I should have. Um, we're going to go ahead and let the endpoints be the labeled points. So there's point A and point B. We see point G, point E right here, point I, and so forth. Now, name all sets of parallel lines. So what lines do you see that are going in the same direction as each other? Try it on your own. You could pause the video and then compare your ideas to what I'm going to come up with too. Practice on your own first. Go ahead and pause the video. Okay, hopefully you've taken a moment to identify the different sets of parallel lines, but we do need to talk about how to name them. We would not call this point or this line here, we don't call it line I. We always need 2 points to name a line. So if you wanted to reference this line here on the left side going up and down, the vertical line one, this would be line IJ, because J is another point on the line at the bottom there. Or you could call it JI. They're both valid. So IJ or JI. Okay, either one is okay. You can, the order of naming it is not important as long as you're picking points that are on that line. So now that we've identified line IJ, that's just a single line. What's a line that you see that is parallel to IJ? Do you see it? What's the other line that's in the same direction as IJ, going up and down? It's this guy here, GH. So line IJ is parallel. That's what this 2 straight up and down lines mean in this symbol. IJ is parallel to GH. Do you see any other lines that are parallel? Not to IJ and GH, but to each other. Straight across, left and right, we've got AB, and that looks like it's parallel to CD. Now, what 2 lines are perpendicular to GH? So identify line GH. That's this guy on the right side going vertically. Do you see? Can you see 2 lines that are perpendicular to GH? AB. And there's one more. CD. Now, I just realized that I haven't been very clear about the naming and the symbols. So pause with me for a moment, and we're going to go back in our notes to near the beginning here. I want to go back up in your notes to here when we talk about lines and segments. So when we name a point, we name them usually with a capital letter, like I did here, A, B, and Y. Now below for lines, it's important that when we write out the symbols, we use the correct symbols and we call it the correct name. So for this example, line AB that I made a picture for, how do we say that out loud? We say out loud, verbally, line AB. Practice at home. This is line AB. Say the word line. Don't just say AB. And also the symbol for it that we can write, you will see problems at Edmentum where they write it this way. We write it as AB, and then we put a line with 2 arrows above it. Now let's look at the segment below. We again have segment AB this time. We say out loud, segment AB. That's how we read that. And the symbol we can write is capital A and B, and either put little dots on the line above it meaning those are endpoints, or just make it a straight line. My computer program where I make our lessons, I can't make the little dots, so I'll just have a straight line above it. These are representing segment AB. And then there's one more I need to go over with you guys, is the rays. So in this example for ray, I had just a single point A. Like our lines and segments, we do need at least 2 points to define it. So this, we would say ray AB. And we write for its symbol the AB again. And this time you're going to put a little ray on top. So it'll have one endpoint and then an arrow. And that you will see these symbols used in Edmentum to signify a ray, a segment, or a line. So it's important to know the difference with the little symbol on top of the letters. Okay, now back to this example. So I should fix, before we move on, let's fix how we wrote our symbols for the first question. Line IJ, we should have little arrows. Line GH, line AB, and line CD. There we go. Because we're calling it a line, we need to show that with the symbols. Okay, next example. Here's what do we see in our picture? We see kind of a number line almost, right? But it's just labeled with some kind of random looking points. So we see point A, B, C, D, and E, and they're all on one straight line. How many unique segments can be found in this set of points? What does that question mean to you? How many unique segments? How many segments here do you see? Can you see segment AB? Let me demonstrate. Segment AB goes from A just to B and stops. Can you see segment AC? Well, that goes from A and continues to C, like this. How many more do you see? There's a lot here. It doesn't seem like it, but there's a lot of segments in this picture. How about A going all the way to D? And A going all the way to E? Are there any more segments that use A? I think that is it. How about segments that don't have A now, since we've exhausted all those segments with A in it? And let's look at starting from B. I'm going to kind of on your notes, you don't have to erase it, so please don't erase stuff in your notes. I'm going to erase the drawing I did on my picture, though. There we go. Okay, so now starting from B, and we're not going to use A at all. So what if we just had segment BC? This is a unique, different segment that didn't exist before in our first list. And what about BD? And of course, there's BE. Now, what if you had named them in reverse? Would that be an issue? What if you named it as segment CB? Is that an issue for us? Is that a different unique segment? No, it's not an issue, nor is it a unique segment. Remember, the naming of a line or a segment can be either direction, either order. So if you list yours as CB instead of BC, that's okay. It means the same thing. Just for example, I'm not going to list all of them in the reverse order, just for example. Okay, now keep going. There's still more segments hidden here. Erase those. How about segment CD and CE? And now kind of keep moving to the right, and there's segment DE. We haven't written that yet, have we? Are there any more? Now we don't want to double count CB and BC. That was just to clarify that we could name it either direction. We could name all of these either order. How many total are those, folks? How many did we write down in our list? 1, 2, 3, 4, 5, 6, 7. And then we've got 8, 9, and 10, it looks like. So, how many unique segments can be found in this set of points? 10 can be found. 10 unique segments. Okay, now an example with circles. Copy down this diagram in your notes, please. So go ahead and pause it if you need to copy down this picture. Draw yourself a circle. I want you to draw a diameter called AB, A on one side, B on the other. And then we've got a radius here from the center O to R. We've got a radius from O to S. So put those on your picture. We've got a random point M that doesn't have any lines going to it. And then on the bottom of the circle, we've got a segment. This is called a chord. A chord is any line segment that is not a radius or a diameter that is connecting two parts of the circle. So this is called a chord, chord DE. And then we've got another random point C right here. Some questions. What four segments do you see that have equal length? What four segments in this picture, in this diagram of the circle, have equal length? What did I mention earlier have equal length in all circles? All radii have equal length. So we have RO and SO. Do you see those? Those are two radii. Do you see any other radii in this picture? How about AO and BO? BO, didn't mean to say that, but that's kind of funny. So we've got four segments that have equal length because they're all radii. RO, segment SO, segment AO, and segment BO. Remember, we could have named them OR, OS, OA, and OB. Let's see. I guess that's it for this. Okay, we'll learn more about circles in the future, but for now, I think we're going to limit it to radius and diameters. Okay, now kind of an algebra problem. Please copy this diagram in your notes. What are we looking at here? We've got point D and several rays coming off of point D. I see ray DA. Here's just some things I want you to observe. What do we see here? We have ray DA. We have ray DB and ray DC. And what else do we see? There's some angle measurements in between some of these line segments or these rays. We need to talk about how to name angles and how to write their symbols as well. So I want to point out the space between starting from A down to D, straight line, and then up to B. So notice this space with me, please. What's the measurement of the angle in between A, D, and B? Do you see it? 46.5 degrees. How do we write that down? The measure of angle ADB is equal to 46.5 degrees. Little m, that means measure for us in geometry. And then this symbol, you can tell, I hope, it means angle. I can't spell it, but it means angle. There we go. And then what is important about the 3 points I've listed, ADB, when we name an angle, you're starting from one part of one of the lines or rays down to the vertex. That's where the lines are meeting. So A to D, and then in the next direction up to the end of that line segment B. A side note I want you all to understand, we can name angles in either order, just like we do with our line segments or our lines. So angle A, D, B, it's okay to also name that the same thing as angle B, D, A. These are equal, but you wouldn't put the D on the outside. The D has to be on the inside of both of these. Notice that D's on the middle here and D's on the middle there. It's in the middle between the other 2 points because it's the vertex in the middle of the A and B in the picture. So the order, you can go in any order you like, but the vertex has to be the one in the middle. Okay, let me change my color and let's look at the lower angle, the bottom angle in our picture. So let's do this in purple. So why don't you really quick practice naming this angle for yourself at home. From B down to the vertex D and then out to C, the other point we haven't used. How do you name that? How do you name that space, that angle? Remember, it's either letter, B or C, vertex, other letter. So we can say this as angle BDC. Or you could say angle CDB. Okay, these are the same thing. What's the measure of angle BDC? What is the measure of angle BDC? Do you see it? The measure of angle BDC is 40.3 degrees. I have another question about this same diagram. Actually, I have several questions. What is the measure of angle ADB? We've already answered this earlier, but locate that. What is the measure of angle ADB? Can you see it? 46.5 degrees. What is the measure of angle BDC? From B to D to C. The measure listed for us is 40.3 degrees. Now, here's the newer, trickier one. What is the measure of angle ADC? From A to D to C like this. How are we going to figure that out? Do we have enough information? Because these two angles are adjacent, meaning they're sharing a side, the top one, ADB, shares this line here, doesn't it, in the middle, with the bottom angle, BDC. That means we can add these two angles to get the entire angle measure for ADC. 46.5 plus 40.3 looks like measure of angle ADC is 86.8 degrees. Now for the larger question at the bottom. If from point D, so from point D, a point E is drawn directly opposite point C so that D, E, and C are on the same straight line, the angle by which AD turns counterclockwise to coincide with DE is what? Now, let's back up, start from the beginning again. Now that we've read through one time, we're going to look at what this is asking us one step at a time to figure out what they're asking. I'm going to change my color to yellow. Here we go. So, if from point D, right here, a point E is drawn directly opposite point C, so that D, E, and C are all on the same straight line. So let's draw that. or imagine that. We extend this line opposite C, and it says we're drawing point E on it right here, anywhere on that line, really, so that E, D, and C are all in the same straight line. They want us to state what is the angle by which AD, let's draw that in again, AD has to turn counterclockwise this way to coincide with DE. So what this is asking us is, how big is this angle here? What's the measure of this angle here? Do we have enough information to answer this question? How big? What is the measure of a straight line? Remember, what's the angle measure of a straight line? We did that earlier in our notes. We know that all straight lines have a measure of 180 degrees. Straight lines all measure 180. Remember this diagram? Don't we have a straight line happening from C to D to E? So that means this entire thing is 180. If we subtract out 46.5 and subtract out 40.3, that will give us the remaining section here, the angle ADE. Try that. 180 minus 86.8, that's the sum of those two smaller ones inside there, right? But we found the question above. If we subtract those in our calculators, what do we get for the remainder, the leftover? 93.2. 93.2 degrees. That is it for this lesson. Now what you need to do is either upload or email a picture of your notes to me, please. This will count as your participation, your attendance. Otherwise, you've been absent from class. Also, we should have enough information in your notes ready to go at this point from this lesson to do the mastery test for mastery test for basic geometric concepts. Two things to do today. Upload your picture of your notes. If you need to fill them out, if you didn't take very big notes, go back and finish them. I want to see all parts that I presented to you, please, in your notes, written down. Then do your mastery test as well. Have a terrific day. I will be back tomorrow, so don't skip class on Wednesday. I'll be back, and we will continue our work in geometry. Bye, guys.